I am Mohammed Anwar MP from Kerala. I have been working here at Springs International School since 2018. Also, I have an experience of 6 years in Saudi Arabia. Overall, I have an experience of 15 years in teaching learning process or teaching learning field. Thank you. So, dear children, I think all of you are fine. See, if you want to know the height of a particular building without using a tape or without climbing it, how can you find the height of a building without a direct measurement? How is it possible? Do you have any idea for that? Or any suggestion? You should find the height of a building without direct measurement. How can we find it? Is it possible or not? Yes. So for that, we will depend trigonometry. As you studied in the last lesson, we will apply trigonometry to find the height of such buildings, or we can use trigonometry to find the height of mountains, or we can use in many aspects. Okay. So today we are discussing the application of trigonometry. Where will we use this trigonometry in our real life? And what are the usages of trigonometry in our daily life? That's what we are discussing today. So just look here. What are the objectives here? See, to understand the concepts of angles of elevation and depression. Have you heard? Do you know the concept of angle of elevation or angle of depression? What is angle of elevation? Anybody? Any idea to anyone? Or angle of depression? Okay. Or we can discuss it. Okay. Then to solve real life problems using trigonometric ratios. So these are our objectives. We will discuss what is the concept of angle of elevation and depression and how to use this trigonometry in our daily life. So by the end of this lesson, you will be able to define what will be the angle of elevation and what will be the angle of depression. Similarly, its real life application. So first of all, let us discuss what is angle of elevation. Do anyone know what is angle of elevation? Angle, I think everybody knows, is it? What is angle of elevation? Just listen here. Suppose an object is at the top of a building, or if you are looking to the top of a mountain. Suppose here is the object. And we are observing from here. See? We are observing the top of a mountain from there. So from here, listen carefully, we will have a, see, this is our ground level. For that, for our eye, there will be a horizontal level for our eye. See, whenever we are looking to the top of a building, for our eye has a horizontal level, is it? So this also, there will be a, see, from here to the object, there will be an imaginary line also will be there. If you are observing, for example, if you are observing the top of this building, see, there will be a horizontal level which is parallel to the ground level. Also, there is an imaginary line to that object. So, this is the horizontal line and this is the, so the imaginary line from our eye to the object, that is called line of sight. So listen carefully. So there is a horizontal level which is parallel to the ground level. Then the imaginary line from our eye to the object. So that is called line of sight. So the angle between this horizontal level and the line of sight, that angle is called angle of elevation. So the angle of elevation is the angle between the horizontal and the line of sight. In such cases, the object always will be at the top. So if you are observing to the top of a tree, the angle between this horizontal and the line of sight will be the angle of elevation. Or if you are watching the top of Burj Khalifa, see the angle between this horizontal level and the top, that line of sight, that is angle of elevation. So did you get the point? What is the angle of elevation? The angle between the line of sight and the horizontal level. That is called angle of elevation. Then, what is angle of depression? In the case of angle of depression, the object will be there at the bottom. Suppose here is the object, and the observer is observing from the top of a building or from the. So as we discussed, there will be a horizontal level to our eye. See, this is the horizontal line which is parallel to the ground level. This is the horizontal. Then from the eye to the object, there will be an imaginary line. That is as we discussed earlier. What is its name? What is the name? Yes, that is line of sight. So there is a horizontal level and there is a line of sight. So as we discussed earlier, the angle between the horizontal and the line of sight, that is called angle of depression. So here we discussed two concepts. The first one is angle of elevation. What is that? What is angle of elevation? The angle between line of horizontal level and the line of sight. There the object or always will be at the top. So when we observe an aeroplane or a balloon at the top or the top of a tree, in all these aspects we will use angle of elevation. Now here angle of depression. The angle between the horizontal level and the line of sight. If you observe a car from the top of a building, if you observe a student from the top, a student who is playing on the ground, if you observe that student from the top of a building, see as I told you, this is the horizontal level and this is the line of sight. So this angle between horizontal level and the ground line of sight, that is called angle of depression. So these two terms, what are the two terms? Angles of elevation and angle of depression. So what is angle of elevation? What is that? The angle between the line of sight and the line of the horizontal level and the line of sight, that is called angle of elevation. Then what is the angle of depression? Can anyone say what is the angle of depression? Yes, the angle between the line of sight and the line of the horizontal and the line of sight, that angle is called angle of depression. I think, is it clear to everyone? Everyone, yes. Now we have studied trigonometric ratios in our last lesson. In the lesson trigonometry, introduction to trigonometry. Do you know what are the different trigonometric ratios that we studied in the previous lesson? Anybody? What are they? Sine, cosine. The next, what is that? Is tangent. Then cotangent, secant, and finally cosecant also. So what is the order? Sine, cosine, tangent, cosecant, secant, and cotangent. And we will use the short forms, right? What is that now? Sine, cos, tan, and what is the next? Cosec, sec, and cot. Yes. And here You can see here I have given a table for you. Can you fill this table? Or can you help me to fill this table? Already you have studied all this and even though we have discussed in the previous one. So can you help me to fill this? Okay, please tell me. What is the value of sine 30? Can you say what is the value of sine 30? What is that? Sine 30, yes, that will be 1 by 2. Then what is sine 45? What is sine 45? Yes. What is that? Yes, 1 by root 2. Then finally what is sine 60? What is the value of sine 60? Yes, what is that? That is root 3 or square root of 3 by 2. If you know the value of sine 60, then easily we can find cos also. Then what is the value of cos 30? Yeah, what is that? Yes, root 3 by 2. Then what is cos 45? What is that? Yes, 1 by root 2. And finally, what is cos 60 degree? Yes, can anyone say what is cos 60? Yes, 1 by 2. Next, tan theta. What is the value of tan theta? Tan 30. Yes, what is the value of, what is it? What is tan 30? Yes, that is 1 by root 3. Even you can find from this ratio also, is it? Because as you know, what is tan? Can express tan in terms of sine and cos. What is that? Tan theta equals sin theta by cos theta. So 1 by 2 divided by root 3 by 2. So from there also we can define what is tan 30. If you simplify this, if you divide this one, you will get 1 by root 3. Here also sin theta by cos theta. Both numerator and denominator are same. So we will get 1. Similarly there also, what is tan 60? Yes, if you divide also, otherwise also you will get. So here we got, that is root 3. So these are the trigonometric ratios that will be used here. So dear children, could you understand what we discussed? The first point is angle of elevation, then angle of depression, then different ratios. Now let us find or let us try to solve a question. That is, how can we apply all these in real life? For that, let us discuss one question here. Just read this question. What is this question? A tower stands vertically on the ground from a point on the ground which is 15 meters away from the foot of the tower. The angle of elevation to the top of the tower is found to be 60 degrees. Find the height of the tower. Can you solve this? Can you solve it? Or can you draw a diagram for the given situation? Is it possible or not? Yes, let us do it. See, a tower stands vertically on the ground. So where is the tower? Where the tower is located? Vertically on the ground. So let us draw a diagram. Listen. A tower. Suppose this is the ground. See, this is the ground. So let's add some more thickness here. Okay. That is the ground. So a tower stands vertically. So assume that here is this is the tower. So this tower stands vertically. So here is the tower. Okay. Then tower stands vertically on the ground from a point on the ground. So this is the ground level. So we can mark a point there. Anywhere we can mark. Is it? So from a point on the ground, suppose this is the point. From a point on the ground which is 15 meters away from the foot of the tower. So this is the tower. So here is the foot. Then here will be the what will be is the top, is it? So from a point on the ground, here is a point, is it? From a point on the ground which is 15 meters away from the foot. So here is the foot. So this distance is 15 meters, is it? So 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is found to be 60 degree. Is it? So angle of elevation. What is angle of elevation? See, what is the angle of elevation? See, object is at the top and the observer is here, and here is the line of sight. So here, see, the angle of elevation of the top of the tower. Angle of elevation of the tower. So here is the top of the tower. So from here to here, the angle of elevation is given. The angle of elevation, see, listen again. From a point on the ground, from this point, the angle of elevation of the angle of elevation of the top of the tower, from this point, that is given as 60 degree. Then find the height of the tower. How can we find the height of this tower? How will we find it? Anybody? Okay, so let's consider this as a triangle. Okay, we are considering as a triangle. And what will be this triangle? It stands vertically. So as you said, the angle will be 90 degree. Now, let me ask you one question. See, we have discussed different trigonometric ratios in the previous lesson. So, for this angle, what is the side of AB? What is this side? Okay, that will be the adjacent side, isn't it? Then what will be the side BC? What is that? Opposite side. Yes, you are right. And finally, this will be the hypotenuse. So as you said, this will be the adjacent side, this will be the opposite side, and this will be the hypotenuse. So what is our question here? Our question is to find the height of the tower. Means we have to find what will be the height of this tower. So in the ratios which you studied in the previous lesson, is there any ratio which includes this adjacent and opposite? And why are we choosing that particular ratio? Here, only in this triangle, we know only this value. What is that value? AB, that is 50 meter. So by using this, can we find this opposite side? That opposite side will become the height of the tower in this particular question. So is there any ratio which consists adjacent and opposite side? Can anyone say? Or do you know what is that ratio? What is that? Yes, it is tan, is it? So here we can use tan theta. So what is tan theta here? What is that? Opposite by adjacent. Opposite by adjacent side. So in this particular triangle, what is the angle here? 60 degree. So we can use tan 60. Is it? Can we use tan 60? Yes. Then what is the opposite side? Means the height of the tower. Yes, that we consider as BC. Is it? So, okay. So BC by, and what is the adjacent side here? What is the adjacent side? AB. Okay. Then what is the value of tan 60? Already we have discussed it. Then also, what is the value of tan 60? Yes, what is that? Yes, root 3. So root 3 or square root 3 equal to BC by, and what is the value of AB? The distance from the foot to the point. What is that? 15 meters. Is it? Now, how can we find BC from there? How can we find? Yes, simply cross multiplication, or we can transpose. Many options are there. So how will we find BC from there? BC equals 15 multiplied by root 3. So we got the value of BC equals 15 root 3 meter. So what is BC here? That is the height of the tower. So we got an easy concept, is it? So this is the application of trigonometry. So how is that? First of all, see, given that the tower stands vertically, and from the foot 15 meter away from a point, from that particular point, the angle of elevation is given. What is that 60 degree, and we have to find the height of the tower. So what we did, we just used which ratio includes opposite and adjacent side. So as you said, that is tan theta. Then we will substitute the values. Tan 60 equal to opposite by adjacent. As you know, tan 60 is root 3. Root 3 equal to BC by AB. That is 15 meter. So finally, we will get that the value of BC, that is 15 root 3 meter. So we can conclude that the height of the tower is 15 root 3 meter. Is it clear to you? Okay. Now, can you do a question like this? Can you solve a question like this? Okay. Now, it's your turn. So, I think the it's very clear to you. Now, please try this question. Yes, listen. From the top of a lighthouse, 60 meter high, the angle of depression to a ship is 45 degrees. Find the distance of the ship from the base of the lighthouse. Okay, in the previous question, we discussed the concept of angle of elevation. And here we are discussing the concept angle of depression. So, can you try this one? So, first we should have an idea about angle of depression. Just look here, what is the angle of depression? Where will be the object? The object is at the pole. And just read this question here also. See, from the top of a lighthouse 60 meter high. So here you can see from the top. And where is the ship? The angle of depression of to a ship is 45 degree. So how can we find this one? So just have a look here. What is the angle of depression? Here is the observer, and here is the horizontal level. And the line of sight, the angle between the horizontal and the line of sight, that is called angle of depression, is it? Okay, now please try this. Okay, how can we solve this one? From the top of a lighthouse 60 meter high. So let us draw a lighthouse here. Okay. Okay, this is the 60 meter 60 meter lighthouse. So from the top of a lighthouse 60 meter high, the angle of depression to a ship is 45 degree. So angle of depression to a ship. So we have to draw the horizontal line. Okay. Then angle of depression. So as you know, how will we draw angle of depression? Yeah. What are the things required to draw the angle of depression? Yes. Yes. What is that now? And what is that now? Line of sight is required. So the horizontal level is needed. Is it? Then one more thing. What we require? What's the next thing? Line of sight. Is it? Okay. So suppose that here is the ship. Then see, this is the horizontal level, and this is the line of sight. So this angle is given. This is the angle of depression, is it? So what is that value? Find the angle of depression to a ship is 45 degree. What is that? 45 degree. Then what is the question? Find the distance of the ship from the base. Here is the base, is it? So find the distance of the ship from the base of the lighthouse. So what we have to find here? We have to find, what we have to find? Yes, what is the distance between the ship and the lighthouse? That's our question, is it? So you can try it, is it? Now you got a little more information about this one. Is it? No. So to do this one, we should find what is the value of this one. Is it? What is the value? What is the distance from ship to the base of to the foot of the lighthouse? How will we find all this? So we can name as a triangle ABC. We can just give a name ABC. Then how will we find? See, horizontal level and the ground level, they are parallel lines, is it? because this horizontal is parallel to the ground level, is it? So these two angles, what will be their value? Equal. Then how are they equal? How do you understand that they are equal? What is that? Yes, alternate angles. So these angles are alternate angles, is it? So let me draw here again. See, here is the lighthouse and here is the ship and here is it. So we can give the name A, B, C, and as you know, what is the value of this angle? Now what is that? 45 degree. And what is the height of this lighthouse? 60 meter. And what is our question? Our question is, we should find the distance between the foot of the lighthouse and the ship. So here we have to find BC, is it? Okay. Then with respect to this angle, what is this? This side AB will be this side, opposite side to it. And what about this? What about the side BC? Now what is that? Adjacent. So we have to find this adjacent side. So say like the previous question, what will we find here? Or which ratio will be used here? What is that? What's the name of that ratio? What is that? Tan. So we can use, as you said, we can use tan theta. So what is tan theta? What is that? Can anyone? Yes, that is opposite by adjacent. So here what is the value of angle? Tan, what is the value of angle? Yes, 45 degree. So tan 45 equals opposite. What is the opposite side here? A. Then what is the adjacent? What is that? BC. Now what is the value of tan 45? Yes, what is that? Tan 45. That is equal to 1. So 1 equal to AB. See, AB is 60. So 60 by BC. From there, you can find what is the value of BC. So what is the value of BC here? Can anyone say? Just do cross multiplication. So BC will be 60. So the distance from the lighthouse to the ship. What is the answer for that? What is the value of that? That is 60 meters. So here, what is our question here? Find the distance of the ship from the base of the lighthouse. Find the distance of the ship from the base of the lighthouse. Find the distance of the ship from the base of the lighthouse. So we got the answer. What is the answer? What is the solution for the given question? That is 60 meters is the solution for the given question. So here this is one of the application of trigonometry. So here in the previous question, what was given? The angle was given as angle of elevation. In the second one, what is it? Depression. So I think you got what's the difference? How to simplify the question if the angle of elevation and depression is given? Is it clear or not? Okay. Now you can. Yes. Please read it and solve it. Now it's your turn, please. A tree casts a shadow 15 meters long. The angle of elevation of the sun is 30 degrees. Find the height of the tree. Yes, can you find it? Please find it. How will we find it? Yes, try it. So a tree casts a shadow. Suppose here is a tree. And it casts a shadow 15 meters long. Normally, how the shadow will start? If normally in the case of human being, our shadow from where it starts? From where? From the foot, yes. So our shadow will be started from the foot only. Is it? Then according to the movement of the sun or according to the sun, the direction will be changed. So here, see, a tree casts a shadow 15 meters long. So a tree casts a shadow 15 meters long. So listen, suppose here is a tree. And shadow from where starts? From where? Yes, foot. Then what is the length of the shadow? Here is the shadow, isn't it? Then what is its length? 15 meters. And the angle of elevation of the sun is 30 degrees. So the angle of elevation of the sun is given. What is the angle of elevation of the sun? The angle of elevation of the sun is given. What is that? Yes. So angle of elevation, as you know, the object will be at the top. So angle of elevation of the sun is given. That value is also given. What is that? That is 30 degree. So a tree casts a shadow 15 meter long. The angle of elevation of the sun is 30 degree. Is it? Then find the height of the tree. We have to find what is the height of the tree. Yes, did we get the answer for the given question? Okay, please. So let us give ABC as the name of this particular triangle. Which ratio will be used here? Here also you can see with respect to this angle or for this angle. This is the this side opposite adjacent hypotenuse. Which one? Yes, this is the adjacent side. And what we have to find, or what is the height of the tree? That side is the opposite side. Okay. So let us find. So which ratio will be used? Already we have discussed two questions. Now we can do it, is it? So what is that? Yes, tan, is it? So we can use tan 30, is it? Because the angle is tan. Then what is the value of tan 30 here? How will we find? How will we find tan 30 here? Opposite by adjacent side. Then what is the value of tan 30? What's the value of tan 30? That is 1 by root 3 equal to AB by, and what is the value of BC? What is that? Yes, 15. Then by doing cross multiplication, is it? Okay. You can do cross multiplication, right? Yes. So if you do cross multiplication, what will you get? Root 3AB equals 15. Then what is the value of AB? What's the value? Okay, AB equal to AB equals 15 by root 3. 15 by root 3. See, is this in standard form? Is it in standard form? So, no, why? What's the reason? There is an irrational number in the denominator. So we have to rationalize it. Is it? So how will we rationalize it? How will we rationalize it? What irrational number is there in the denominator? So by that we should multiply both. Yes, numerator and denominator. So let us do it. So what will we get? Let us multiply numerator and denominator. So what will be the numerator? What is 15 root 3? 15 root 3. Then what is the value of root 3 in root 3? Root 3 in root 3 will be 3. Now can we simplify it? Can we simplify this? Yes. How many 3's are there? 1. And here how many are there? 5. So what's the answer? 5 root 3. Is it? So here you can see 5 root 3 is the value of AB. Actually, what is AB here? AB is the height of the tree. So very simple. So we just discussed the same concept here, is it? How to find the unknown values, maybe opposite or adjacent side. So in this question also we used the concept of, or we used trigonometry here. So this is the application of trigonometry. And here you can see, here the angle of elevation is given. And from the what was the question? Find the height of the tree. So similarly, we can find the height of the building, height of the tower by using the same methods. And one more question here. So let's move to the next question. Is it? Okay, now read this question. From a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degree and 60 degree respectively. Find the height of the tower. Read the question carefully, and this also you can find it. But you should read the question carefully. That's it. From a point on the ground, the angles of elevation of the bottom and top of the transmission tower fixed at the top of a 20-meter high building. So what the question says? See, the transmission tower is from the transmission tower fixed at the top of a 20-meter high building. What is the transmission tower? Transmission tower is fixed at the top of a 20-meter high building. So how will we draw the diagram? Suppose this is a 20-meter high building. This is the 20-meter high building. And where is the transmission tower fixed? This tower is fixed at the top of this. Here is the tower. Is it? Here is the tower fixed. So transmission tower is fixed at the top of a 20-meter high building. Is it? Now just read the question again. Now you can draw the diagram. From a point on the ground. See, here is the ground level. So from a point, suppose it's a point. From a point on the ground. From a point on the ground, the angles of elevation of the bottom and top of a transmission tower fixed at the top of a 20-meter high building. See, the angles of elevation of bottom and top of a transmission tower. So for this transmission tower, which will be the top? Here will be the top. And where will be its bottom? Yes, here. Is it? There will be the bottom of the transmission tower. Now just read the question. From a point on the ground, the angles of elevation of the bottom. Angles of elevation of the bottom. Is it? That is given. What is that? Elevation of the bottom and top. And their values are given as 45 degree and 60 degree. Is it? So from a point on the ground, the angles of elevation of the bottom and the top of the transmission tower. And where is the transmission tower? Fixed at the top of a 20-meter high building. Is it? So that values are the same. Angles of elevation of the bottom is given as 45 degree. And the top, that is also given. What is that? 60 degree. So this is the diagram. So we can draw it neat. We can draw a neat diagram. So here is the ground level. And here is the building because transmission tower fixed at the top of a 20-meter high building. So here we can give, as we discussed, this will be 20-meter high building. Then transmission tower. That transmission tower is fixed at the top of a 20-meter high building. So here is the building. And here is the tower. Okay, then the angles are also given. What is the angle? Angle of elevation of the bottom is given. That is 45 degree. And the top is given as 60 degree. So find the height of the tower. We have to find what is the height of this tower. So we can give some names for this A, B, C, D. So we have to find what is the height of the tower. Okay, can you find it? So this is a vertical tower, right? So this angle will be 60. How can we find this one? Can you solve or can you find what is the height of this tower? See, here 20 meters is given. Then we have to find this one. How can we find it? First of all, can you find this AB from here? Is it possible or not? Can you find AB by using triangle ABC? Is it possible or not? Can you find out? Now it is very easy to find, guys. Then by using that particular value, can you find the next? Yes, right. So listen. How can we find? So for that, see here, consider the small triangle. So here in such situations, we can use the two right triangles, is it? So how will we use these two right triangles? Triangle ABC. Okay. So triangle ABC. First let us consider triangle ABC. Just drawing triangle ABC. And this value, as you know, 20. And in this triangle ABC, what is this angle? Yes, 45. 45. Then, how can you find AB from there? How will you find the value of AB from there? Yes, as we discussed, yes, is correct. We can use tan. So, we can use tan 45. What is the value of tan angle here? 45. That is opposite by adjacent. That means what is the opposite side here? BC by adjacent will be AB. So what will we get? And what is the value of tan 45? Yes, what's the value of tan 45? That is 1. Then BC will be 20 by AB. Is it? Now can you find what is AB? Yes, AB equals 20. So we got the value of AB from there. Is it? We got the value of AB from there. So this AB equals 20. Then, so we got AB equal to 20 meter. Is it? So we consider this small right triangle. Is it? Now we have to find CD. This CD is located in the bigger right triangle, right? So let me draw that right triangle. This is it. Okay. Then we can name this, right? Or we can write these lines. A, B, and here is D. Okay. Then what is the value of AB? What's the value of AB? Will be 20 meter. And here in between this BD, one small point is there, right? C. Then also I am just marking C. Then what is the length of BC? What's the length of BC? Here's 20. And this angle is, as you know, that is 90. And what is triangle ABD? What is the value of A? A will be 60. Then here also, can we use? See, here already 20 is and the value is to find. That is CD. Where is that CD? That is on which side? Opposite side. Yes. So here, adjacent side is given and the value which is to find is on the opposite side also. So adjacent, opposite. So which ratio includes this both? Adjacent and opposite. Which is that tan. So we can use, as we said, tan 60. What is tan 60? Opposite by, what is the opposite side here? B by adjacent, that is AB. So opposite by adjacent. Then how can we find it? See, what is the value of tan 60? What is the value of tan 60? What is that? Yes, root 3, square root 3. And BD is the distance from here to there, right? So how can we write, how can we split them? Can we split it as BC plus CD? So BC plus CD divided by, what is the value of AB? Already we got it. It is 20. That is root 3 equals BC plus CD. What is the value of BC? 20. So 20 plus CD divided by 20. Then, as you know, what we will do from there? Yes, we will do cross multiplication. So we will get 20 root 3 equals 20 root 3 equals 20 plus C. Now, can we find CD from there? Because that is our question. What is our question? Find the height of this. Is it? So, can we find CD from there? Yes, possible, right? So, we can transpose 20. So, 20 root 3. Then, if you transpose, what will happen there? The value will become, yes, a negative. That is equal to CD. So, this will be the value of CD, and you can see we can take common factors. Yes, it's 20, we can take it as a common factor, and you will get root 3. Then, from if you are taking 20 from there, yes, 1 will remain. So, that is the value C. So, here you can see the questions. Here is a combined figure. Is it combined figure of two right triangles? So first what will we just choose one right triangle. Then we got the value of one unknown side. Then afterwards we just applied it on the next triangle. So here first we choose the first right triangle, and from there we got the value of AB. Is it? Then applied in the next triangle, and finally we got find the height of the tower. Here CD is the height of the tower. So we got CD equals 20 into square root 3 minus 1. Okay. So we should be able. So these are many applications of trigonometry are there. This is also one of the applications of that. Now we can do one more question. Okay. See, IUA based question. Yes. A drone is flying at a height of 200 meters, observes the base of Burj Al Arab at an angle of depression of 30 degrees. Find the horizontal distance between the drone and the building. Okay, suitable for UAE contest, is it? So a drone is flying at a height of 200 meters, observes the base of Burj Al Arab at an angle of depression of 30 degrees. So can you draw the diagram of the question? How will be the diagram? Where the drone is flying at a height of 200 meters, is it? It's flying at a height of 200 meters. I observe the base of Earth. So the drone is flying at 200 meters, is it? So suppose here is the drone. Here is the drone. It is flying at a height of 200 meters. At a height of 200 meters. And what is it doing? Observes the base of Burj Al Arab at an angle of depression of 30 degrees. Okay, see, observe the Burj Al Arab at an angle of depression. So, horizontal level and the line of sight. So, here will be the Burj. See, observe the base of Burj Al Arab at an angle of depression 30 degrees. So, as you know, there will be a horizontal level and there will be a, what is that? Line of sight. Observe at an angle of depression of 30 degrees. Then find the distance between the drone, find the horizontal distance between the drone and the building. Find the horizontal distance between the drone and the building. Is it? So, what is the horizontal distance? Okay. So we have to find the horizontal distance between the drone and the building. Okay. So listen. So we can draw a neat diagram for this. So here is the okay. So look here. Here is the horizontal tower, and this angle is 30 degree. So this will be parallel to the ground level. So this also will be 30 degree. Is it? So this angle is 30 degree. And what is the height of this one? Height is given as 200 meters. Then the horizontal distance between the drone and the building. So what we have to find here? So here, given that this value will be 30 degree and the horizontal distance, is it? So let us find BC from there. What will be the value of BC from there? We can use the ratio tan, is it? We can use tan from there because we have discussed many questions, is it? So here is the opposite, and what will be this? What will be this? Is the adjacent side. So which ratio will be used? What ratio will be used? Yes, tan 2. What is tan? Opposite by opposite by. Here what is the opposite side? AB. So AB divided by BC. And what is the value of tan 30? What is the value of tan 30? Yes, that is 1 by root 2 equal to AB. What is the value of AB? 200. And BC will be, that is to find, is it? That is to find. Now, as you know what we will do, yes, we will do, yes, cross multiplication. So, this into 1 will be the same. Then, yes, root. So, that's distance. Suppose, if you want to find AC from there, which ratio will be used? If you are finding AC from there, which ratio will be used from there? What will be the ratio? Yes, what will be that? Yeah, side, very good. What's the reason? Because for this right triangle, this is the opposite side. And what is this? Hypotenuse. Good. So hypotenuse is there. So which ratio includes opposite and hypotenuse? So you just find AC also. That is 2. Okay? You just find it AC. So understand how to apply this. Yes, is it clear how to understand these values, or how to find the height of the building, how to find the height of the mountain, or how to find the distance between the foot and another building? So like we can apply trigonometry everywhere. So let's move to another question. See this question, a simple question. A 15-meter ladder leans against a wall forming at an angle of 60 degrees with the ground. Find the height it reaches on the wall. A 15-meter ladder leans against a wall forming an angle of 60 degrees with the ground. Find the height it reaches on the wall. You just try it. It's easy, right? Isn't it? Very easy. It's good. So what is the question? A 15-meter ladder leans against a wall. Is a wall. A 15-meter ladder leans. See, a 15-meter ladder leans. 15-meter ladder leans against a wall, forming an angle of 60 degree with the ground. See, forming an angle of 60 degree with the ground. Is it? Okay. Find the height it reaches at the wall. So, what we have to find actually? We have to find, yes, the height of this wall. Good. So, how will we draw the diagram? See, here is the wall. Then, you need a ladder, is it? So, here is the ladder. Then, how will we find? The length of the ladder is given. Is it ladder leans against a wall, forming an angle of, what is the angle? 60 degree. with the ground. Then what is the length of the ladder? Is given 15 meter. Then find the height it reaches on the wall. Is it? So how can we find? So if you are considering this as a triangle ABC, then what we have to find here? Yes, we have to find AB. Yes, good. Then which ratio will be used here? Which ratio can be used? Oh, see, include for this triangle, AC is the hypotenuse. Good. And what we have to find? AB. What is that? Yes, opposite side. Very good. So what's the name of the ratio? Its name is what is that? See which ratio includes or opposite and hypotenuse. Where can we see this ratio? So what is the name of the ratio? What is it? What is the name of the ratio? What is that? Yes, good. Sine. So sine. What is sine theta? Opposite by hypotenuse. Very good. Opposite by hypotenuse. And what is the value of theta? What's the angle here? The angle is 60 degree. Then sine 60 equals opposite. That is to find AB by then hypotenuse. What is the value of hypotenuse? AC. Then what is the value of sine 60? What is the value of sine 60? Please. Yes, come on. What is the value of sine 60? What is it? Yes, good. Root 3 by 2. So, root 3 by 2 equals AB by, then opposite by hypotenuse. What is that? 15. Now, normally how will we do? Yes, we'll do, okay, cross multiplication. If you do cross multiplication, you will get 2AB equals 15 root 3. Then what is the value of AB? AB equals 2. So 15 root 3 by 2. So how will we simplify from there? 15 by 2. What's the value of 15 by 2? Yes, 7.5. So 7.5 root 3 meter. That is the height of this wall. Means where the top of the ladder touches the wall. So here what ratio we used? Sine. So many questions are there, many applications are there. So we can find any unknown values. Okay, so here you can see the height of the wall is 15 meter. Okay, so we discussed many questions, right? And where can we apply all this in our real life? See, many applications are there. Architecture and construction field. Everybody knows, isn't it? Because these engineers, they will use this concept of application of trigonometry in construction and in navigation also. Sailors and these adventures, those are doing this adventure in the ocean, they will use this trigonometry for navigation purpose. Engineers and in astronomy, even to find the distance between the stars and celestial bodies, like space, everywhere using. Even surveying, they are always using. Everywhere it is used, especially mainly used in surveying also. And in physics, medical imaging like MRI scanning, CT scanning, BCG, many options are there in the medical field. And computer graphics and game development, music, sports, even in art also. So everywhere it is used. So it is used everywhere, like you see in architecture and construction, navigation, engineering, astronomy, surveying, physics, medical imaging, computer graphics and game development, music, sports, arts, everywhere it is used. So many real life applications are there. I just noted some of these only. Now, what did we discuss today? So what are the main points that we discussed here? We discussed many points here, right? What are they? Yes. What was the first point that we discussed? What is that? Angle of, yes, elevation, depression, and then many questions. Now look, this is our question for you. What is one real life application of trigonometry that you learned today? Yes, what is that? Many we discussed, right? Mainly we discussed. Just now in the previous session, just in the previous slide it was there, right? Now what are they? Can you see all these points that we discussed? Is it? Then there is a homework for you, like a homework. It's a research how trigonometry is used in navigation. How it is used in navigation. That's a research work and it's a homework for you. Okay? And solve three additional textbook problems on heights and distance. So these two are the homeworks for you. So dear children, so today we discussed application of trigonometry and many questions. Is it? So what are the main points that we have to what we discussed today? The first point is, see, what is our objective today? To understand the concepts of angle of elevation and depression. Is it? So we discussed it. So I think it's very clear for you. And to solve real life problems using this trigonometry ratios. This was our objective, and now I think we achieved it. What was it? See, I think now you are able to define and explain the angles of elevation and depression. Also, we can use many trigonometry problems in our daily life. Okay, so and we discussed angles of depression, elevation, and many real life questions. Okay, so thank you. Have a nice day. So, okay, thank you.